Add and subtract and simplify radical expressions containing rational numbers with variables by Riley Hoiback and Evan Grace. Block 1. First example is simplifying a radical equation. The problem that we will be simplifying is the cube root of 128 a to the 4th b squared c to the 7th. The first step is to find perfect cubes within the numbers and variables. 128 has the perfect cube of 64 times 2. A to the 4th has a to the 3rd. B squared has nothing. And c to the 7th has c cubed times c cubed times c. After the first simplifying step, 4ac squared goes on the outside of the radical, and 2ab squared c goes on the inside of the radical. 4ac squared times the cube root of 2ab squared c is your final answer.
For this next problem, we're going to add and subtract radical expressions. When asked to add or subtract radical expressions, you may be presented with a problem like this, or similar to this: 3 times the square root of 32 plus the square root of 162 minus 4 times the square root of 9. To solve this type of problem, first you need to find a perfect square out of the 32 that multiplies evenly with another number to equal 32. In this case, I use 16 and 2. Next, you would do the same thing for the square root of 162, which I used 81 and 2. However, you don't need to do this for the 9, for it is already a perfect square. Following that, you will square root the perfect square and multiply it with the number in front of the square root. In this case, I squared 16 to get 4 and multiplied it with 3 to get 12 on the outside. The remaining number, 2, stays on the inside of the square. Again, you will do the same thing for the 81 and the 2 to get 9 on the outside and 2 on the inside. You will also square root the 9 and multiply it by the outer 4 to get 12, and then carry down the signs from the top. After you get the equation shown in red, you need to combine like terms. Since the first two terms both have the square root of 2, you can combine the outer numbers by adding them to get 21. The 12 on the outside stays where it is. Finally, the equation should read 21 times the square root of 2 minus 12. Here's another example of how to simplify. For this next example, it requires you to simplify the square root of 121 times x to the 6th times y to the 2nd times z to the 5th. To solve this, first find the perfect squares in each of the variables. For this problem, 121 is a perfect square of 11, so we can skip over that for now. Since x is raised to the 6th power, the square root of the function can go into 3 times. Y is raised to the 2nd power, so it can only go into it once, and z is raised to the 5th power, so it will go into it evenly twice, and you will have 1 left over. You then need to move each of the evenly squared variables to the outside of the root and raise them to the power of however many variables could go into it evenly. For example, since x to the 6th can be brought down 3 times, it would read x to the 3rd on the outside of the square. Finally, you need to add in absolute value bars around each odd-powered variable in the outer portion of the equation. Since x cubed and y cannot be negative, they need to contain absolute value bars around them. So the final equation should read 11 times the absolute value of x cubed y times z squared times the square root of z.
To be continued at a math class near you.